All right, so we're starting with hydrochloric acid, and if we add zinc, which is a solid, it's a metal, one of the products that zinc can produce is hydrogen gas and zinc chloride, which zinc chloride would be our aqueous solution, and then hydrogen is a gas. So if we were wanting to find out how much hydrogen gas we can make, so the I guess layman's way of doing this is you just grab whatever hydrochloric acid you have and whatever zinc you have and you throw it together and hope you get some product. But of course that's not very effective. So I'm going to color code this. So for this one, we're going to use hydrochloric acid is going to be in purple. And we're going to start out with 5 grams of hydrochloric acid. And then I'm going to do zinc in orange. And we're going to say that we have 5 grams of zinc. And then our unknown is going to be hydrogen gas in liters. So just like we've done before, we've gone from mass to mole to mole to mass, or we've gone mass to mole to mole to volume, or volume to mole to mole to volume. Now in this example here, we're not going to be at STP, so our pressure is going to be equal to 1.25 and our temperature is going to be at 25.0 degrees Celsius. So this mixes it up, so we cannot use straight stoichiometry, so we do need to convert at some point in time using PV equals nRT. And I'm going to show you guys a little shortcut for how to solve for limiting and excess reactant and theoretical yield without going all the way through. Yes, Zach? The pressure is in ATM. Thank you for clarifying that. All right, so Olivia, you had a question also? That stands for X is our variable of unknown. L stands for liters. Yeah. Hold on, need some water. While you guys were doing your homework, I ate Chex Mix and now I have a really dry throat. All right, so the first thing that we need to do is what we traditionally do, and that is step 1. We're going to convert grams of each reactant to moles of each reactant. So this is why I'm doing it color coded. So I'm going to keep everything in HCl in blue or purple and everything in zinc is going to stay in orange. So if I start with hydrochloric acid, we have 5.0 grams of HCl. And we need to get to moles of HCl, so we need 1 mole on top. And then HCl is going to be on bottom. So I have 35.45 plus 1.01. So we're going to have 36.46 grams per 1 mole. So I'm going to take my 5 and I'm going to divide that by the 36.46. And what I get is 0.137 moles of HCl. And again, I'm going to do the same thing with zinc. So I have 5.0 grams of zinc. And then my molar mass for zinc is equal to 65.39 grams. So 5 divided by 65.39 will give me 0.0765 moles. So if I just look at this, it looks like I have a lot less moles of zinc than I do of hydrochloric acid. And so I might say, all right, zinc is the limiting reactant because I have less zinc than hydrochloric acid. But that doesn't necessarily mean which one is going to produce the least amount. So we do have to go back up and we have to look at the balanced equation. So this is not balanced currently. So we need 2 hydrochloric acids to 1 zinc to 1 hydrogen to 1 zinc chloride. So this is just like on our second step for stoichiometry, where we need to convert grams to moles, then moles to moles. So step 2 is convert moles of reactant to moles of product. So we have 2 products that we need to go to. However, the only one that is the unknown that we want to solve for is hydrogen gas. So we'll just go to hydrogen gas. We don't have to worry about zinc chloride. Zinc chloride would just be our waste product that we're not worried about. So going back to our color coding, starting with our zinc chloride. So we have 0.137 mole of, actually it's hydrochloric acid, HCl. And so we need mole of HCl below. And then we're going to go to mole of H2 above. And from our balanced equation, we have 1 mole of hydrogen gas is equal to 2 moles of hydrochloric acid. So that means that this value of 0.137 needs to be divided by 2. So we get 0.0685 moles of H2. So if we've done it now for hydrochloric acid, now we need to go ahead and do the same thing for zinc. So for zinc, we had 0.765 moles of Zn. And then we have mole of Zn below, and then mole of H2 on top. And when we look at our balanced equation, we have a 1-to-1 ratio. So 1 mole to 1 mole. So we have 0.0765 moles of zinc. Yes, Daisy? Nope, you are correct. That should be H2, not zinc. Thank you. Because our mole of zinc canceled. So you are correct. It's mole of H2. So normally we would go to mass here, but we have to go to volume here. Now here's the thing. It doesn't matter when we're at mole. We don't really need to go to volume at this point in time. We can look at these 2 numbers and determine which one is our theoretical moles. So as a refresher, how do you determine which of these numbers, or what to do with these numbers to find theoretical yield? What would I do with these numbers? Yes, Daisy? Yeah, it's how much can be made from the limiting reactant. So if we're looking at these two items here, would hydrochloric acid be the limiting reactant or would zinc be the limiting reactant? So zinc produced the smaller or the bigger mass or number of moles? It's not, no. So look at you're close though. Like I think I see where you're trying to go here. Zinc is your excess one because it's produced more moles of hydrogen gas. So hydrochloric acid is your limiting because it produces the least amount of moles. Yeah, so this one here, hydrochloric acid, is going to be our limiting. I'm just going to put LR for limiting reactant. And then zinc is going to be our excess reactant. So theoretical moles is how much is made, and it is the smaller of the two numbers. All right, so theoretical moles is what we need to figure out. So in this case, whatever produces the smaller amount, which is this one, is going to be our theoretical moles. And then as a refresher for the other terms, so we have limiting reactant. And so our limiting reactant is the reactant that runs out. First, and it produces the smaller moles of product. And limiting reactant, what I wrote up there is going to be noted by LR. And then if I look at the excess reactant, so our excess reactant is the reactant that is left over. And it produces a number of moles of product greater than possible for the reaction. So our excess reactant is going to make something that's too big. So we run out of the limiting reactant, and so the excess reactant cannot make how much it could have made if it had not run out of the other reactant. And so again, our excess reactant I wrote up above as XS. Get it? Excess reactant. It just makes it easier. All right, so now that we have found that this number here, the 0.685 moles of hydrogen gas, is our theoretical moles, how do we get our moles of hydrogen into liters of hydrogen? How do we get moles of hydrogen gas into liters of hydrogen gas? Yes, Zach? So if we do that, we're not at STP. So you could do that, and then you're going to have the value of what it's at STP, and then you would have to use the combined gas law to convert it into the correct pressure and temperature. So you can do it that way. It's a little bit longer, but it does work. Connor, what's another way that we could do it? There are a lot of formulas. Can you help me figure out which formula to use? That is correct. We're going to use PV equals nRT. So I forgot what number I had stopped at. So we're at step 2. Wow. Okay, there we go. Now we're on to step 3 finally. Oh. So step 3 is to convert the moles, or the theoretical mole, to volume of product. And so from our up above number, the one that we had that we can use is 0.685. So we're going to use 0.0685 moles. And we're trying to solve for V. So V is nRT over P. So we have our N, and then our rate constant, we're able to use 0.0821 because we're in ATM. And then our temperature was 25 degrees. So 25 plus 273 gives us 298 Kelvin. And I need to go back and look at what my temperature was, or pressure was that I gave it. So pressure was 1.25. So our pressure was 1.25 ATM given in the problem. So 298 times 0.0821 times 0.0685, it gives me 1.68, and then I'm going to divide that by 1.25. And the volume that I achieved is 1.34 liters of hydrogen gas. So are we done? So let's go back up. What was our objective for today? Our objective was limiting and excess. Did we determine the limiting reactant? Yes. Did we determine the excess reactant? So we didn't solve how much excess was left over, but did we identify the excess reactant? Yes. So when we look at this, was hydrochloric acid or zinc our limiting reactant? Yes. So this one, yes, go ahead, Robert. Thank you. So our limiting reactant was hydrochloric acid. So we ran out of hydrochloric acid first. And then our excess reactant was the zinc. So let's go back and double check. So limiting reactant, that's correct. All right, and were we at STP? No, that's right, because we were not at 1 ATM and we were not at 0 degrees Celsius. So we have formed our objective all in those notes today. So what we're going to learn tomorrow, just a heads up, is that we are going to learn, so tomorrow, what we're going to learn how to do is to calculate excess reactant remaining, And we are also going to determine percent yield. So those are more of a refresher, and the remaining is not spelled that way. It's hard to write with your finger. I still haven't found my Apple Pencil. It's either here floating around or at home, so just using my fingers. Not too bad for writing with my fingertips, I hope. All right, so let's go ahead and look at what tonight's homework is going to be. All right, hold on. Let me just move this screen so I think there's possibly, it's also on there. Trying not to show grades. All right. So for tonight's homework, you guys are going to be doing something similar to what I did, but you only have to do it with one reactant. You don't have to do it for two. Yay! But I like doing the two so you guys get some practice on it. So tonight's homework, what you guys are going to do is you're going to complete the following question on a separate sheet of paper so you can show your work. And so you're going to assume that you have 5.60 liters of hydrogen gas at 1 atm and 20 degrees Celsius. And it's going to react with unlimited copper 2 oxides, so it's not your limiting reactant. And you want to start first by balancing the chemical equation, then determine how many moles of hydrogen gas are in this problem, then how many moles of hydrogen or water vapor are in this problem, and then how many liters of water vapor are produced. So I went through 2 examples with you guys, and I went over which one was limiting and excess. So you don't have to do limiting and excess in this one. You're just practicing going from product or reactant to product. So for those of you guys who feel pretty confident and don't have any questions, you are allowed to leave at this time. And the rest of you guys that want to stay for additional questions, you are welcome to stay, and I'll be here until 3:30.